So, good afternoon, students. Let's start our seminar. So this week, students, we have started our new topic, right? So, choosing when to act. In the previous two topics, two sessions, we have discussed about choice with risk. But this week, we will discuss about choosing when to act. All right? So students, because utility of different days or different occasions is different for people, okay? It's going to be different. Every day we experience different level of utility. So therefore, today we are going to consider a model in which we are going to consider if there are different days to choose between different utilities, then there is one utility among all of them, okay, if I decide to do it in specific day, then it's going to give me the highest utility. The highest. So now, therefore, students, we have several calculations for today. Today we will use three models, okay? Exponential discounting model, hyperbolic model, and quasi-hyperbolic. Those three models you must understand. And next week, we will have another model, okay, which we are going to consider, which one is a bit more advanced than these three models that we are going to cover today, okay? These models are not difficult at all if you understand. It's very simple, but you should just simply understand what does it mean, okay? What does it mean? All right, so discussion and exercise 1, students. Question 1, what is intertemporal utility function? What is intertemporal utility function? That's the first question that we have to address. Okay, what was it, students? So this week, I don't know why, the number of students who attended the lecture was very low. Okay, very low. After that coursework presentation, it seems that you got somehow relaxed. Don't get so relaxed, okay? Because the real change is coming soon, okay? That real change is coming soon. So look, intertemporal utility function. So which means that we are going to consider utility function which considers timing, overall timing. So what will be that utility of 1 week or utility of 1 year or 1 month if I am going to specifically do some action in different days, all right? Because we can do some action on specific days. It's totally up to us. But our decision of doing things in different days will give us overall utility which will be different, okay? But there will be one utility which is going to maximize or optimize our decision, okay? So that intertemporal utility function means that one. Second one, what is utility function with exponential discounting? Exponential discounting. So students, in exponential discounting model, we are considering that people usually do not see utility of today exactly same for tomorrow. People try to discount. So what was that exponential discounting model? So how was it look like? So we consider that utility function for time t, okay? So utility of, let's say, first day or first month, utility of the second month, and so on. Utility of the last time, last day. All right, now we are considering utility of different days or months, timing, okay? And then, students, we are seeing that in the first day, first utility, we see it as it is. First day utility as it is. But from the second day, utility of the second day, we don't see it as it is. So then we will try to discount. So utility of the second day will be discounted by discounting factor. We are discounting it. And for day 3, students, we will be discounting exponentially. Okay? So now our discounting factor will get larger. Okay? It will get larger. So now I'll explain. Because I'm saying that it will get larger because our delta is between 1 and 0. The lower the delta, the larger the impatience level. So I will explain you, don't worry, okay? So now, then this is for third day, and so on. And the last one, our delta, our time t, last one minus 1 times utility of that last day. Now I will explain. We have, you will understand.
Isn't it the second power? You wrote 3 sigma.
Oh, sorry, it's 2, right? It's 2, sorry. Yeah, it's 2. It is 2. It's 2, and so on. And then overall, if you are going to write it, then it will be sum of, right? Sum of our delta t minus 1 times our utility in period t. So this is that overall function of exponential discounting model. Okay, this is the model that we are going to consider. And students here, what we should know is what this delta is. All right, this discounting factor. So that's next question. What is delta, and how do we know it? This one. So it means that how people are patient. It shows that people's patience level. Patience level. So let's say if my delta is equal to 1, it means that I do not distinguish of today's utility with the utility of tomorrow. Okay? For example, let's say if I am saying that $1,000 sums of today, do you see it as the same that value, the 1,000 sums for tomorrow? Do you see it as one, let's say 1 month later? Do you see that the same? If you think that yes, 1,000 sum of tomorrow and 1,000 sums after 1 month, I do not distinguish. It's same. Okay, it's same money. I see it as same. But it means that your patience level is 1. You are a very patient person. You do not discount. But if people, let's suppose, after 1 month, because normally in Uzbekistan inflation rate is relatively high, then purchasing power of 1,000 sum is going to be lower. All right? Then you don't see 1,000 sum of today as 1,000 sum after 1 month. You see that purchasing power will go down. So it means that your delta is now smaller than 1. If it's 0.9, let's say 0.9, it means that after 1 month you see this 1,000 sum as 900. You are discounting it. You are discounting it, okay? By 10%. So it means that one, your patience level. So the smaller the value, more impatient the person is. Okay, impatient, which means that that person wants to get that 1,000 sums as early as possible. For the person who is one very patient person, 1,000 sums today and 1,000 sums after 1 month is no problem. Okay, no problem. This is students that delta, so discounting factor. And how do we usually find discounting factors, students? So discounting factor is equal to 1 over 1 plus rho. This rho means discounting rate. Discounting rate. Discounting rate. So here, if you would like to find that discounting rate, which is next question, how do you find it? And from here you can find, right? Rho. So if you just multiply this denominator to the left side, then you will get your rho is equal to 1 minus delta over delta. So this is how you find discounting rate. So students, in our today's seminar and the following week seminar, we will be considering using only discounting factor. Okay, discounting factor. This one you should know. And how do we usually find it? And how do we usually find it? Look, in order to find out about people's patience level, experiments are conducted and people are asked questions. People are asked questions. Similar to this one. Look, Suppose you prefer receiving $100 today rather than receiving $105 after 1 month. Having $100 in your hand, find the discounting factor and then discounting rate. So which means here, students, we have two options, okay? I'm asking the students, now, you can get $100 now. Or, if you want, there is another option, you can receive $105 after 1 month. When similar questions were asked from people, most of the people, they chose now. I want to get $100 now. Okay? So which means that now we are preferring $100 over $105, which can be received later after 1 month. So now, if most of the people are answering like this one, of you are answering, then I can easily find your delta, your patience level. It means that your delta patience level is equal to 100 over 105. If you divide it, then you will get 0.95. What does it mean, 0.95? 0.95 means that, for example, $100, or if you multiply, that 0.95 to 105, it will be equal to what? Do you have a calculator? Can you calculate it, please? So if you put 0.95 times 105 is equal to 99.7. Okay? So now you see that $105 you see as $99. So why do we calculate? Because now I chose $100 today, right? I have said I am not going to choose $105 after 1 month because people are discounting it. This is discounting factor. Okay, discounting factor. People are seeing this $105 as $99. Now I'm seeing for me it's now $99. Okay, after 1 month they see it as $99. So therefore people choose $100. Okay, patience level. So this is how we usually find that, students, discounting factor. Once you find it, discounting factor, you can easily find discount rate applying this formula. So if you would like to find that raw discount rate is equal to 1 minus delta, which is 0.95, over 0.95, which is equal to, if I'm not mistaken, it's 5%. Okay? 5%. So now this is discount rate. Okay? Discount rate. So, students, we have found discount factor, and discount rate, both. And now here, students, we are asked, find possible utilities that you may get from $100 after 1 month, 2 months, and 3 months. Because after 1 month, now, I see $100 as $100 now, okay? Now, I see $100 as $100. But after 1 month, I don't see it as $100. Because after 1 month, I am discounting it. So which means that how much I am discounting? 0.95 times 100. So next period utility, I see it like this one, which means that I see $100 after 1 month as 95 utility. Let's say $100 gives me 100 utility. So then that now $100 after 1 month gives me 95. units of utility. Okay?
Like multiplying discount factor, yeah?
Yes. So after 1 month I am discounting. Second month, students, I am discounting exponentially because it's longer period of time. Which means that now 0.95 in the power of 2 times 100. Okay? So now if you calculate this one, let me see. I think I have done some calculations here just for the sake of saving time. It is 90.3, right? 90.3. Which means that I'm seeing $100 as $90. Okay? As 90. At month 3, 0.95, my discounting factor in the power of 3, right? Is equal times 100. This is equal to 85.7. 85.7. So now, students, how we are seeing it? Because we discount, so over time, we see that after 1 month, so this is first period, this one is second period, this is third period, this is fourth period. Okay? Now, next month. So after 3 months, I'm seeing that $100 as $85. Okay? So this is how this is. So which means that now this 0.95, it means my patient's level. The larger, in other words, the smaller that delta, more people become impatient. If it's close to 1, people are patient. If it's close to 0, people are impatient. Okay? Impatient. Good. I think, students, now it's clear. So now we'll exercise 2 where we are going to do the calculations. All right? During the lecture, I explained, it's not tried, I explained how to read this data. Okay? How to read this table. Please quickly read. So students, here now we have a table, okay, which gives us statistics of 3 students' utility. All right? 3 students' utility. So on Friday, okay, on Friday, first table, first column. So now utility that students get on Friday is 0. No utility. Regarding -2, I will explain. Okay? If you attended the lecture, then you know what that -2 mean, okay? So now on Friday gets no utility. Why it's no utility? Because you have to go to school, to university, you have to study, which you really don't like, okay, which is somehow this utility, but at the same time you meet your friends, yeah, you are a little happy, so that, you know, that happiness and unhappiness is now 1-to-1, now you get nothing. Okay, it's 0. But on Saturday, you get utility of 3. Because you don't go to school, you play sports, you play soccer, whatever. You play sports, you enjoy it, then it gives you utility of 3. On Sunday, again, you don't go to the university, you watch TV, you spend time with your family, then you get utility of 4. All right? Utility of 4. And on Monday, normally you don't get any utility, but we have these numbers. These numbers. What does it mean? Now I will quickly explain. So look, according to this task, those students are given homework. Okay? Assignment is given, and that homework is given on Friday. On Friday it's given. And the deadline is on Monday. Okay? Monday is deadline. So which means that in between of Friday and Monday we have Saturday and Sunday. Right? So it's totally up to you what day to do your homework. If you want, you can do it on Friday, if you want on Saturday or Sunday or Monday. Normally our students choose which day? Monday. Okay, normally our students try to delay until Monday and a few hours before the deadline. Okay? So now we will be modeling and calculating such behavior today. All right? So, Friday, Saturday, Sunday, or Monday. Look, on Friday, I finished my classes. I'm very tired. I'm a student. I left the school, went home, and I decided to do my homework. I did my homework. I submitted online the same day, okay? And on Monday, I had utility of 2. Utility of 2, which means that because we are very tired, the quality of your work will not be so good, and the mark that you are receiving will be relatively low. And now you are happy, but a little happy. Okay? On Friday, then I decided to do my homework on Friday. On Saturday. On Saturday. So I got rest. Okay, I'm very, fresh. Then I did my homework. And I submitted, that day. But on Saturday, I spent the entire day doing homework. Okay? Then if I do my homework on Saturday, you can see that on Monday I will be very happy. So it means that the quality of the work will be really good. Because I did it with my fresh mind, everything is fresh, cool, good, quality work. Okay? I did it. So look, students. Here we are saying that if those students decide to do their homework in particular day, if they decided to do it on Friday, then it means that it will cause this utility of 2. Doing homework, no one's like doing homework, right? It's burden. We must do it anyway to pass. So doing that homework causes this utility, which is negative 2. So look. Normally, we don't get any utility, but if you decide to do your homework on Friday, then you will experience this utility of 2, minus 2. Here, I'm going to do my homework on Saturday. Do it on Saturday, okay? Do it on Saturday. So which means on Friday I will not do my homework. But on Saturday, I will do my homework, which means I don't have time to play sports. Whole day I am spending for doing homework, which means that I am experiencing this utility. Or I may decide to do my homework, okay, on Sunday, which means that on Friday I'm not doing my homework. On Saturday I'm playing sports, but on Sunday I am doing my homework. On Sunday. I'm not watching TV and not spending time with my family. I'm in my room doing my homework, which is this utility, okay? This utility. And if I decide to do it on Monday, then I'm not doing anything, no this utility in these days because I'm not doing my homework, but I will do it on Monday. And I will submit very low quality work same day, okay? So it means that one. So students, you must be able to read these tables. Okay? So now, if I do it on Friday, so this utility will be on Friday. If I decide to do my homework on Saturday, so this utility will be on Saturday. If I do it on Sunday, this utility will be experienced on Sunday. If it's Monday, it will be on Monday. Okay? This is it. So look. Considering the case that students have different patience levels, so which means their delta is different. their delta is different. In other words, student 1, 2, 3 have discounting factors of 1, 0.8, and 0.5. So now, student 1 is very patient student. Second one is a little impatient, but student 3 is very impatient students. Okay, student. So now, find intertemporal utilities with exponential discounting model that I have shown you earlier. We will apply that model, so which is our exponential intertemporal function for exponential discounting model is, so utility of log, utility of Friday, utility of Saturday, utility of Sunday, and utility of Monday equal. In the first day, okay, first day we do not discount, so which means the utility of Friday will be as it is, but we will discount the utility of the following day, utility of Saturday, and we will discount even more the utility of Sunday, delta square times utility of Sunday, and we will discount even more the utility of the last day, discounting factor in the power of 3 times utility of Monday. So now we have to apply this formula and calculate for 3 students. For 3 students. Now we will do it together. We will do it together. So first one, student 1. Student 1. His patient level is 1. Very patient 1. He does not discount anything. He sees $100 today as $100 after 1 month. Okay? So let's do it. So now he is deciding. Now it's Friday. Now I finished my school. I went home. I am deciding. Should I do it? What if I do my homework today? Okay, I'm deciding. What if I do it today? What will be my overall utility? Intertemporal. So now, utility of Friday. So I'm deciding I will do it on Friday. So okay, if I do it then, it will cause me this utility of 2, right, on Friday. This one. Then, so I will experience this utility, and tomorrow I will not be experiencing this utility, and I will get utility of, I will play sports 3, but I discount it, which is delta is equal to 1. Second, so in that Sunday, then I'm discounting the Sunday by 1 in the power of 2 times utility of 4 on Sunday because I watch TV. Okay? And plus the last day, 1 in the power of 3 times 2. So if you calculate it, students, you will get the number of 7. It's equal to 7. It's equal to 7. So if I decide to do my homework on Friday, then my utility overall, 4 days utility will be equal to 7. So then, okay, if I do it on Friday, then it's 7. What if I do it tomorrow on Saturday? So utility of Saturday. It means on Friday I will not do my homework. Normally I don't get any utility, which is 0, right? Plus. But tomorrow I am doing my homework. Can I play sports? No. It means that on Saturday I will experience this utility. Okay, this utility. Plus, and on Sunday I can play sports, okay? 1 in the power of 2 times 4 plus, and on Monday I can see my really nice results and I'm very happy, okay? And overall, if you calculate this one, it's equal to 10. Is it 10? Yes, right? I think it's 10. 10. Next one. Now, So it shows that if I do it on Saturday, then it seems that my utility will be more, higher. Now I'm deciding, what if I do it on Sunday? So then you will calculate, so now, what if I do it on Sunday? Then on Friday I will not do anything, so now normally it's 0. And on Saturday I will play sports, okay, then it gives me utility. But on Sunday I decided to do my homework. Which means that on Sunday I will spend doing time doing homework, then it will cause me this utility of 2. Plus 1 in the power of 3 times 8. If you find this one, it's equal to 9. It's equal to 9. All right, it seems that if I do it on Sunday, my utility will be 9. Okay? What if I do it on Monday? All right? So what if I do it on Monday? All right? On Friday, no utility at all. On Saturday, I will play sports. On Sunday, I will watch TV. But on Monday, I have to do my homework. Minus 2. And this is equal to 5. It's equal to 5. So, what will be the first student 1's decision? So, I will do my homework on Saturday because it gives the highest level of utility. Okay, the highest level of utility. All right. So now this is for a person who is patient. Who is patient. So now we will calculate, students, for a second student who is a little impatient. Who is a little impatient. So, student 2. Student 2. So now, student 2 is doing same decisions, okay, decisions. So now he said, okay, what if I do it so because here is the delta students is equal to 0.8, all right? So, all right, let me see. What if I do it today, on Friday? On Friday, if I do it, then it will be this utility of minus 2, right? Because I'm doing it on Friday. Plus, on Saturday, then I can play sports. On Sunday, I can watch TV.
Isn't it 0.8?
Oh, sorry. Yes. Thank you. It's not 1. So it's 0.8. Yeah. 0.8, right? Because it's impatience. I confused with this one. So times, I can play sports plus 0.8 square times 4 plus 0.8 cube times 2. Times 2. So if you do this calculation, students, so you will get the number of 3.98. It's equal to 3.98. I think you are following me, right? Okay. So now, all right, if I do it on Friday, then it's going to be my utility. What if I do it on Saturday? He's now thinking. All right? So then I will not do any homework on Friday. No utility normally. But I will do it on Saturday. So which means that I will experience this utility of 2 minus 2. And on Sunday, I will watch TV plus. And on Monday, I will get really nice results. So now, if you are going to calculate this one, then it will be 5.6. 506. 506. Okay? 506. So it's equal to this one. All right? It seems that doing homework on Saturday for the student is better than doing it on Friday. So what if I do it on Sunday? Okay? Utility of Sunday. If I'm doing on Sunday, then on Friday I will not do anything. On Saturday I will play sports. But on Sunday I will not watch TV. Okay? So therefore it will cause this utility. Alright? Plus 0.8 in the power of 3 times 8 equal to 5.22. It seems that doing homework on Sunday is better than doing it on Saturday. What if I do it on Monday? Utility of doing on Monday. So now 0 plus 0.8 times 3. I think you are following me, you know, right? 0.8 squared times 4 plus 0.8 in the power of 3 times minus 2, which is equal to 3.93. 3.93. What will be the decision of student 2? So student 2 is going to do his homework on Sunday. Okay? Because it gives the highest utility. So now, students, we have a student with very, very impatient student. Okay? Which really works well with our students. All right. So now, student 3. His impatience level is large, 0.5. Okay, 0.5. So now he's deciding same thing. So now, what if I do it on Friday? If he is going to decide this one, so on Friday he will experience this utility, right? Minus 2 plus 0.5, right? Because it's his impatience level, discounting factor, times 3 playing sports plus 0.5 squared times 4. Is it 4? Plus 0.5 cube times 2. This is equal to 0.75. Next one. Okay. What if I do it on Saturday? On Friday, I will not do anything, so it's normal. But on Saturday, I will do my homework, where I will experience this utility, plus 0.5 squared times 4, plus 0.5 cube times 8, right? And it's equal to 1. So it seems that doing homework on Saturday is better than on Monday or on Friday. Utility of Sunday. 0 plus 0.5 times. I'm playing sports. I'm having that utility. But on Sunday, I'm doing my homework, which is this utility. Okay? Plus 0.5 cube times 8, which is equal to 2. It seems that for this student, doing homework on Sunday is better than on Saturday. So now his question, what about if I do it on Monday? All right. No utility on Friday. 0.5 times 3, I'm playing sports. On Sunday, I'm watching TV, okay? But on Monday, I'm doing my homework. And it's equal to 2.25. All right? 2.25. So look, now we have to compare these three ones. If you compare these three outcomes, who gets the highest level of utility? Student, number 1, okay? A person, who is delaying doing his homework, he is getting less. But he delays up to until the last day, he gets the minimum one. So it tells you that students who really try in advance, they can produce really good quality coursework and they can get really good mark. The ones who delay until the last moment and even submitted late submission, very bad, and deduct from this one, we will deduct a bit 10% of the mark. Okay, this is how students usually behave. Okay, so it means that this is evidence. So students who do it in advance, they really get the highest mark and they're very happy. And the outcome is really good. Okay, so which means that delta, larger the delta, it means that closer to 0, people's impatience level gets larger. Okay, good. I think now it's clear. Exercise, we are done with exercise 2. We are done with exercise 2. Next, discussion and exercise 3. Discussion and exercise 3. What is hyperbolic discounting? Here is the question, students. Explain the difference between exponential and hyperbolic discounting models. So students, now we are making a strong assumption that people's discounting factor will not change. If my impatience level, if it's 0.8, then it will be same. Okay, this impatience level will not change. It's exactly the same. All right, it will not change. And it is the case. So annual discounting, for example, factor. In the case of exponential, people's patience level is same. Does not change. But when experimental labs were conducted, so when people were questioned, so those experiment results show that people's patience level increases with time. With time. For example, what does it mean? For example, someone asked me, so, you can get $100 now. But if you have that, there is a possibility of delaying it and receiving later after 1 month. If you want to delay, receiving the money after 1 month, how much do you want? Do you still want exactly the same or a little more? A little more, right? Okay, if the 1 month, $120 will work for me. It's okay. I'm happy. Okay, I'm ready to delay it. Okay, good. All right, so we can find discounting factor. Okay, discounting factor. And then I'm asking, all right, so this one. Now, you can get $100, but there is a possibility of delaying for 1 year. 1 year. So, what do you say? How much would you be willing to accept if you are going to delay it 1 year? Most of the people said, if you pay me $150, I'm very happy. What if it's delayed to 10 years? Okay, just pay me 3 times more. I'm happy with it. So look, students. When it's 1 month, right? For 1 month, they are asking extra $20. For 12 months delay, they are asking only $50. They are not asking for each month $20. People are becoming more patient, discounting less. After 10 years, now you can see their patience level increased much more. 10 years, okay? 10 years. So here, they are not 1 year, if it's 50, they are not asking 500. Or they are asking less. So which means people's patience level change. It's not like this, if it's 1, 1, 1, no, or 8, 8, 8, no. Here, it is, let's say, 0.8. After 1 year, it became 0.85. After 10 years, it became 0.95. People become more patient. So this is how people responded. Okay, people's patience level increased. So students, because that real life cases showed like this one, it means that our discounting model, exponential discounting model, will not work if people behave like this one. It will not work. So therefore, we need a better model, which is hyperbolic discounting model. Hyperbolic discounting model controls for people's increasing patience level. Okay? Increasing patience level. So now I'm erasing it. So this is second model that we are going to discuss for today. Okay, second model. So regarding exponential discounting model, I think it's clear, right? So look, suppose we have $100 and the annualized discounting factor of exponential discounting that we have discussed now is equal to 0.85. And hyperbolic discounting is equal to 0.25. So look, regarding students, exponential discounting model, we know, right, our utility of t for different utilities of timing, right, t, we said it's equal to sum of, we discounted, right, t minus 1 times utility of t. So it was. And regarding students, our hyperbolic one, we have again, you know, same type of utility function, okay? Utility function, where our, you know, that utility of first day and so on, the utility of the last day is equal to sum of, here, we are not going to use that exponential one, okay, exponential discounting, but we use hyperbolic discounting, which is dt, and utility of t. So now we should know it. Regarding delta, we already know, right, what delta is equal to now here? 0.85, right? And here, students, our hyperbolic discounting model, during the lecture I showed you, in order to find it, is equal to our hyperbolic discounting model is equal to 1 over 1 plus alpha t minus 1. T minus 1. Where alpha is given for us, alpha is equal to 0.25. So now if we are going to apply it, it will show us how people's, you know, patience level over time increases. Indeed, okay? So find the possible utilities for periods 2, 6, 9, and 10. For both we will find utility. For period 2, students, for period 2, exponential one. So now if I'm going to apply it for just period 2, 0.85 times 100, which is equal to 85, yes? Period 6, for period 6, students, for period 6. So now, 0.85 in the power of what? 5 times 100. It's equal to, I think I have those calculations, let me find. It's equal to 44.37. 44.37. For period 9, 0.85 in the power of 8 times 100. If you find this one, it's equal to 27.25. Is it? Find for period 10, which is 0.85 in the power of 9 times 100. It's equal to 23.16. Okay? So now it shows that of course, indeed, you know, we are discounting it, right? We are discounting it over time. And now let's apply hyperbolic discounting model. How much do we see $100 after 1 month? Okay, period 2. So now, period 2. So 1 over 1 plus alpha is equal to 0.25. Our t, period 2. 2 minus 1, right? Right, this formula, times 100. If you find this one, it will give you the number of 80. We get utility of 80.
Where did we get that? 0.859, 0.858.
You mean powers? Here. So in the first period, okay. So if you don't understand, it's a good thing to ask, because in the final exam I will not answer anyone's question. So it means that now first day, okay. So here, now let's say delta in the first one, $100. First day is 1 minus 1. So here 0.85, 1 minus 1 times $100, right? This is equal to 1, because it will be that 0, then it will be 1. I see $100 and $100. Tomorrow is second day, 0.85. I don't see it, you know, as 1. What? 2 minus 1 times 100, which is equal to 85, and so on.
Yes, I got it.
Okay? Good.
So we, like, for the second period 6, we...
So period 6, now 6 minus 1, it's 5. Okay? Good. So then period 3. Period 6, students. Period 6. 1 over 1 plus 0.25. 6 minus 1 times 100. If you calculate this one, it will be equal to 44.44. And then for period 9, 1 over 1 plus 0.25, 9 minus 1 times 100. 33.3. And then for period 10, 1 over 1 plus alpha 0.25, 10 minus 1 times 100. This is equal to 30.8, right? 30.8. So, do the results really show people's, you know, that patience level increase over time? Look. Here. In second period, we see it as $85. In period 6, we see it as $44, right? Here, initially, we discounting it more in a short period of time, okay? Now we see it as 80. But period 6 is now almost same. But after period 6, now you can see people's patience level was indeed increasing. Okay? Then this one. So it shows that people's patience level increase over time. Okay? Over time. So now, students, here, if you divide 23.16 to 27.25. Can you divide it, please? Oh, just a second. 0.85 in the power of 9. It will be equal to 0.23. And now, students, try to find this one.
0.3.
Is it 0.3, right? 0.3. So now, in period 3, people's patience level. In period 10. This in period 10 is 0.3. People's patience level is now higher. Okay? People's patience level is higher. Now, it is 0.3, but day is 0.23. And now, if you now calculate for longer periods, you know, this patience level here, it will be getting larger and larger. It will be, the difference will be much more. Okay?
So the hyperbolic is more realistic, right?
Hyperbolic is more realistic. Hyperbolic, because people indeed become more patient. Okay? People become indeed more patient. So students, let's continue. So now, this is exercise 4. Okay? So look, people were asked questions, all right? Group of people were asked the following first question. Do you want $100 today? So today. Do you want $100 today? Or $110 tomorrow? $110 tomorrow. So most of the people, they said, we want $100 today. Okay? Most of the people, they said, we prefer $100 today. So second question was asked. So, do you want, you know, that $100 in day 30, okay, in day 30. So $100 after 100 days, okay? So after 30 days, $100, or $110 after 31 days, in day 31. Which one would you like to choose, okay? So most of the people, the answer to this question, I prefer $110, even though the difference is 1 day. Okay, 1 day. So in the first question, we would like to have $100 today, but in the second one, we would like to have $110 in day 31. So that was the case. So now we will try to explain, okay, why was it, you know, that does it have any meaning? Why there were people, you know, mostly they were preferring $100 for today and $110 in day 31. So now we will try to people's behavior with hyperbolic discounting model. Okay? So look, day one. Today. Hyperbolic discounting model. How much utility people get in, from $100 today? You know hyperbolic discounting model, 1 over 1 plus alpha is equal to 0.25. So it's today means day 1. 1 minus 1, which is equal to 0, times 100. So people see $100 as $100 now, because it's $100. Okay? But tomorrow is future. People, they discount it. Tomorrow. 1 over 1 plus 0.25. Now it's second to period 2, 2 minus 1 times 100. Times 100. If you do the calculations of this one, it will give you the number of 88. So it means that people see $110. Oh, sorry, it's 110. It's not 100. 110. Okay? 110. So tomorrow, period 2, $110. So if you calculate this one, you will get 88. So which means people actually see $100 of tomorrow as $88. So they are discounting a lot. Okay, they are discounting a lot. Good. And you will find from here how much they are discounting. Okay, how much they are discounting. Good. So now it makes sense why people are choosing today. Okay, it makes sense. Good. What about this day 31 and 30 and 31? So we can apply in day 30, 1 over 1 plus 0.25, day 30 minus 1 times how much? 100. If you calculate this one, it will give you the number of 12.12. 12.12. In day 31, $110. 1 over 1 plus 0.25, 31 minus 1 times 110. If you calculate this one, you will get the number of 12.94. 12.94. So does it make sense that people's choice was right? So people are actually, because over time, in the longer period of time, patience level has increased, right? So now they see it now as high. Okay, good. So now people's decision based on hyperbolic discounting model can be explained. Can be explained. All right. And now we have second question, students. We have proved it. What would happen if people have present biased preferences? So look. Today, tomorrow, right? Today I decided to choose 100 rather than 110. Day 30 came. Day 30 came. Then, when I am in day 30, is it going to be today again? Day 30. Now I'm in day 30. 29 days passed. Now it's day 30. Now it's today. And it will be tomorrow. It will look like this. Right? Some people, student, when it happens that if people, they decide, okay, from now, I'm choosing, all right, I'm choosing, $110 in day 31. If people indeed, in day 31 choose $110, then it means people have no bias. No bias. But when day 30 comes, they see it, it seems that today utility is higher than tomorrow. Then they change their mind. All right? Because they see that day 30 as today. And they change their mind. If they change their minds, it means that people have bias. Present bias. Okay, now, present bias. So therefore, students, such behavior, which is changes with people's biasness, cannot be controlled with or explained with hyperbolic discounting model. In order to explain it, people's, decision which was made now should be consistent. If it's going to be time inconsistent, then hyperbolic discounting model is not able to explain it. Okay? So therefore, because it cannot explain people's biased behavior, we have another model, which is quasi-hyperbolic discounting model. Okay? Quasi-hyperbolic discounting model. Now, in this model, we are including people's biased behavior. In exponential discounting model, we said that it does not control for people's increasing patience level. But in hyperbolic, we said that it does not control for people's biased behavior. So therefore, we would like to introduce you quasi-hyperbolic discounting model, which looks as follows. So utility for period 10, okay, the T, utility of first day, utility of the second day, and so on, utility of last day is equal to. So people see presencing as it is. $100 as $100. So which means that they do not discount for day first, or there is no bias to right now. People's bias will appear with future outcomes. Okay? So therefore we will include here plus beta. Beta. So this beta is describes people's bias behavior. And people at the same time, they try to discount, okay, t minus 1, utility of t. And here, students, t starts with period 2, okay? With 2. You don't have to forget. So now, this is quasi-hyperbolic discounting model. How is it different? Here now we have included present bias preferences parameter. Okay? It shows how people are biased, so how much, present bias level. Okay? Okay. Students, during the lecture, I have explained what this model is, all right? And I showed you some numbers which were calculated with these given numbers. So again, now we are considering, students, three type of people. So now, first, with beta is equal to 1, with beta is equal to 0.9, with beta equal to 0.8. People's patience level is same, 0.9, 0.9, 0.9. But their biasness is different. If beta is equal to 1, it means that people have no bias. So if I said I will do it tomorrow, I will do it tomorrow. But if I have bias, then it means that when it becomes tomorrow, then I will say, what if I do it next day? When it becomes tomorrow, the following day, then I will change my mind again. So I will be procrastinating. All right? So I will do my homework today. So when today, I will do it, I think, tomorrow. When tomorrow, I think I will do it. You will delay it until last hour of the deadline. Okay? So that type of students have very large bias. Okay? Which is close to 0. Okay? Close to 0. So look, now, with doing some calculations, you will understand. So now, again, that homework assignment question, but numbers are different. So now, utility on Friday usually we get is normal is 0, we don't get. On Saturday we play sports, so we get utility of 5. And on Sunday we watch TV and enjoy some other things, we get utility of 10. And on Monday, based on the quality of the work that we have submitted, we will get the marks, okay, which are good or bad. Based on that one, we will see how much utility we will get on Monday. All right? On Monday. So now we are given present bias and people's patience level for different people. So first person, second person, and third person. So now I will show you how to calculate for the first person and for the second person. Okay? Third person. Second one is homework for you. Because if you are able to do it this one and this one, you will be definitely able to do this one. Just for the sake of time saving, we will consider only 2. All right? Good. So look, according to this one, students, so let's do it. Now, I'm a person, let's say, with no bias. Okay? My beta is equal to 1. I have no bias. But I am a little impatient person. I'm a little impatient person. So I am considering this first case. So look. So now today is Friday. I am deciding to do it on Friday. What if I do my homework on Friday? Okay, now it's Friday. Now it's Friday. Now it's Friday. Okay, on Friday, I'm applying this quasi-hyperbolic discounting model. Friday. Okay, good. If I do my homework on Friday, then I will experience this utility on Friday, right? Minus 5. Minus 5. Plus. In the second, then, I have biasness of 1. Okay? 1 times patience level, which is 0.9. In the power, because it's period 2, it will be 1, right? Times, I can play sport. So it's 5. Plus. 1 times 0.9 times second power, right? 10 plus 1 times 0.9 in the power of 3 times 4. If you calculate this one, you will get the number, just a second, let me see, I have here, those calculations, 10.5. 10.5. Next one. Utility of Saturday. So now, on Friday, I am thinking, what if I do it on Saturday? Okay? So now, 0, because I am not doing my homework on Friday, so it's now 0 plus 1 plus, multiply. Beta is same, yes, because we are considering this beta. Times 0.9 times, I'm doing my homework, minus 5 plus 1 times 0.9 squared times 10 plus 1 times 0.9 in the power of 3 times 10. If you calculate this one, you will get utility of 10.9. 10.9. It's
two rows there.
so now I will explain, because it's quasi-hyperbolic discounting model. All right? So now we are considering it's Friday. Okay, on Friday. This is our decisions. So what if it's going to be on Sunday? So on Sunday, I'm not doing homework. 0 plus 1 times 0.9 times 5, right? Plus 1 times, I'm doing my homework on Sunday. Square times minus 5 plus 1 times 0.9 cubed times 10. If you calculate this one, you will get the number of 7.7. 7.7. And then utility of Monday, I'm not doing it on Saturday, on Friday plus, and I am playing sports on Saturday, and I am watching TV square on Sunday, but I am doing my homework on Monday. 0.9 in the power of 3 times minus 5. If you calculate this one, it will give you the number of 9. It will give you the number of 9. So on Friday, students, on Friday, so which day is going to give me the highest utility? Do it on Saturday. So now, today is Friday. I decided to do my homework on Saturday. I decided to do my homework on Saturday. Okay? On Saturday. So now this is my decision. So now listen carefully, understand this part, okay? What is important? Friday is gone. I said I will do it tomorrow on Saturday. Now it is Saturday. Okay, now I am in Saturday. Friday is gone. And now when it became Saturday, now I am thinking, should I really do my homework today? Okay? Should I really do my homework today? Which means that now this Friday data is now gone. So now we need only Saturday data from here. These three columns data. Okay? Friday is gone. Now Saturday, now I have no bias. Okay, no bias. Let's see. What will be his outcome? Okay? So now Saturday. Now Saturday is today. Okay, Saturday is today. So utility of Saturday. First day is now utility of, I'm doing my homework. Should I do it today? If I do it today, then it will be -5 plus. Then tomorrow I will watch TV. 1 times 0.9 times 10 plus 1 times 0.9 squared times 10. So if you find it, it will be 12.1. 12.1. All right, on Saturday, what if I do it on Sunday? What if I do it on Sunday? So then on Saturday, I will play sports, which is 5, right? Plus 1 times 0.9. On Sunday, I will do my homework, -5, plus 1 times 0.9 squared times 10. If you calculate this one, it will give you number which is equal to 8.6. 8.6. 8.6, okay? And then, what if I do my homework on Monday? Utility of Monday. All right, I will play sports today, which is Saturday. And tomorrow, I will watch TV, okay, which gives me utility of 10. And on Monday, I will do my homework. 0.9 square times -5. And it will give you the number of 10. Yes, 10. So what is my decision to do my homework? Today. Oh, today, Saturday. Because I have no bias. I said I will do it tomorrow, then I'll do it. Okay? So now we will consider people who have bias. So here we consider a person, I will do it tomorrow, then he will do it tomorrow. A person who has relatively higher level of biasness.
Here, for example, during calculating it when it's Friday, what if our highest utility is on Monday, let's say, and we should calculate by...
Then if it's Monday, that's it. If it's going to be here, let's say you got it Monday, then you will do it on Monday. Because now it's not. If it's, utility function, it's because these numbers, if the numbers are different, you will get different things, okay? So now, if it shows you that Monday, then it means that you will definitely do it on Monday. But if it shows Sunday, when Sunday comes, you will calculate again. Should I do it today or tomorrow? But if it shows, Monday, you are lucky enough, then you don't have to do any more calculations. But in the final exam, it will not be looking like this one. Okay? It will be something in between if you have such question.
But even if the beta is equal to 1, is it necessary to calculate this one? Because there is no bias anyway.
So therefore, I will not give you beta equal to 1. Okay? I will not give you that one in the final exam. Don't worry. I will not spend your time. I will not spend your time. All right, now let's consider a person with bias, okay? So now we are saying that beta is equal to 0.8, okay, this third person, okay? And delta is equal to 0.9. Yeah?
Regarding the second part,
Yes?
tomorrow?
No, no, no. It was Friday. I decided, I did calculations, and it shows that tomorrow is best choice, okay? Friday is gone. Now I am on Saturday. When it became Saturday, I'm thinking, should I do it today? All right? It's like this. So it shows that because I have no bias, then I will do it today.
One more question regarding timing. So you're considering Friday the first day?
Yes? Friday is first day of Friday, first day, Saturday is second day, Sunday and Monday. Okay? Good. All right. Utility. So it's Friday, students. Now we are considering Friday. Okay, Friday. We are considering those biased people. So now, what if I do it on Friday? Okay, Friday. So if I do it on Friday, then I will experience this utility of 5 plus. Then on Saturday, I have bias, okay, of 0.8 times. I'm a little impatient person, which I'm discounting my utility of playing sports. 5, okay? 5. Is it 5? Yes. Plus, so again, 0.8 times 0.9 times 10. I watch TV. N power of 2. Yes, power of 2. Plus 0.8 times 0.9 in the power of 3 times 4. Friday, yes? If you calculate this one, you will get number which is equal to 7.4. Okay, that intertemporal utility for quasi-hyperbolic is doing homework on Friday is equal to 7.4. So on Friday, I'm saying, what if I do it on Saturday? What if I do it on Saturday? So then on Friday, I will not do my homework. No utility or this utility plus. And I'm a little, I have present bias of 0.8. And I'm discounting, okay, that my utility of playing sports. So here it's now, because we are going to experience, doing homework on Friday, on Saturday. So it's now this utility plus 0.8 times 0.9 squared times 10, right? Plus 0.8 times 0.9 cubed times 10. And if you calculate this one, it will give you the number equal to 8.7. 8.7. So what if we do it on Sunday? 0, 0.8, 0.9 times I play sports. I can play because I will do it the homework next day. So 0.8 times 0.9 squared times minus 5 plus 0.8 times 0.9 cubed times 10. So if you calculate this one, students, you will get number which is equal to 6.2. And if I decide, what if I do it on Monday? So on Friday, no utility. On Saturday, I play sports, okay? I play sports. On Sunday, I watch TV with my present bias and my discounting factor, okay? 10 plus and 0.8 times 0.9 cubed times minus 5. If you calculate this, it will give you a number 7.2. So, what is my decision? So look, based on my calculations, I said that I will do my homework on Saturday. Okay, a student who has present bias. Student said, I will do it on Saturday. Friday is gone, and now it's Saturday. Saturday came. Friday is gone. So now, the student is questioning, should I really do it today? Okay, should I really do it today? And he will do same calculations. Okay, today is now Saturday. Utility of Saturday. If I do it on Saturday, then I will experience this utility plus next day is 0.8 times 0.9 times 10. Plus on Monday 0.8 times 0.9 times 10 in the power of 2. 0.9 in the power of 2. If you do these calculations, it will give you number of 8.7. 8.7. And what if I do my homework on Sunday? So on Saturday, I will play sports plus 0.8 times 0.9 times minus 5 plus 0.8 times 0.9 in the power of 2 times 10. 10. I think you are all following, right, those numbers. And it will be equal to 7.9. It shows that doing on Saturday is better than doing on Sunday. What if on Sunday, or on Monday? Utility of on Monday. So now, on Saturday I will play sports plus on Sunday 0.8 times 0.9 times I will watch TV, which is 10. Utility gives me utility. And plus I am doing my homework, 0.8 times 0.9 squared times minus 5. If you calculate this one, it will give you the number which is equal to 8.96. All right? What will be his decision? On Monday. All right? On Saturday I said, I will do it tomorrow, but the next day I changed my mind. I will do it on Monday. Okay? So, it becomes because of this present bias, students. Okay? If people have that large present bias, which is closer to 0, so they will be procrastinating, delaying. I will do it tomorrow. When tomorrow comes, I will do it the next day, the next day, the next day, the next day, until the last moment. Okay? And how these people's procrastination, delaying things, can be controlled. How can we solve this problem? How can people solve if you have such behavior? This is the reason why you are giving deadlines. Okay? If deadline is not given, you will not do it forever. This is one reason why that deadlines is given. For example, if you are planning to visit your, for example, grandmother or mother who lives abroad, you will be delaying, okay, maybe next month, maybe next month, maybe next month, I am busy. But one way of, controlling for this, you have to make a commitment and buy a ticket. If you buy a ticket next month, that's it, you will go. So which means that it's one way of controlling for your bias behavior. So students, our class is over for today. If you have any questions, yes?
Here, should we also recalculate it on when it's Sunday? For example,
You don't have to. So now, that's it, because once on Saturday I said on Monday I will wait until this one. But let's say in the final exam I gave you similar question. It turned out to be it turned out to be Sunday. When it's Sunday, then you have to do another calculation. Okay, now Saturday, then it became Sunday. Oh, Sunday. One day Saturday is gone. On Sunday people think, should I do it today or tomorrow? You have to do another calculations.
Then we'll get Monday.
All right? So anyway, there are 2 days, whether it's going to be Sunday or Monday, anyway, it will be that day. Okay? So last two. So students, you can go. So now we are done.